Hi everyone and welcome to this video. This is the 11th video I think of the series, and we're on chapter 6 of the official book Getting Started with MicroPython on Raspberry Pi Pico. I've shown you it many times in the series. I'm actually really frustrated at the moment. Look at the quality of this, hang on. Let me just move this into the view. Okay, so there's the camera. I put my hand on, look, the quality is really good when it focuses. So what I've done, let me just show you, because the quality was so bad in the previous videos, I've bought this. I'll just move this out of the way. I bought this, a brand new Logitech C922, because it was highly recommended on YouTube for YouTube videos. It was good in low light and all that. So I've paid this, got it here brand new boxed, and quite frankly it's poor, really poor. Anyway, that's what we've got to work with. So there it is. I'm going to use this again because this is my newest camera, my newest webcam, allegedly excellent quality, but it's not. It just doesn't focus, although it does there. So I don't know. What I'll have to do is I'll have to pick it up like this. There's definitely got to be something wrong with it. Anyway, getting on with the video. So we're making a reaction game, and this is called mental chronometry. Mental chronometry, and it's to do with the speed and reaction time of people's brains. Apparently, the average reaction time is 200 to 250 milliseconds for an adult human. Presumably children would be faster maybe, and older people would be slower, but I don't know. So let's just get on with it. I guess I'll have to just move it up like this now and again and hope that it focuses. Oh look, it's focused. It's really good when it does focus. Anyway, I'll stop moaning and get on with it. So we know this one's the cathode and we know this one's the anode. Oh yeah, I forgot, I'll have to do that. Cathode is the shorter leg and the anode is the long leg, which is the plus. We're going to put this in here, just over there like that, across the whatever that's called, middle piece, spine or something I suppose it's called. Then we're going to put the 330 ohm resistor in here, spanning the last pin to the anode of the little LED. So I'll just show you this again. Oh, I knew it would do this. You going to focus? No, I didn't think you would. Oh, there we go, it's focused. It focused for a split second. Anyway, so what we've done... Oh, look at that. Oh, yeah, it's good, it's good. Okay, so we've gone from the last pin to the anode. Why can't it... Oh, hang on a minute. If I put it really close... Wow, look at that. Alright. So I think I just need to put this camera closer. But look at the quality when it does focus. Anyway, going off on a tangent. So next we need to put the quick reaction button in place. Sometimes these buttons are different. Now on mine, those two are joined together and those two are joined together. Sometimes you might have it the other way around and you might have to get a different button, or you might have to rotate it or something, but this is how my button works. So we want a ground wire. Let's see if I've got one here. I sometimes use blue for ground, but we want to go from the LED ground to the ground rail. So I use the ground rail this time. I don't always use the ground rail. So the idea is this big strip along here. Oh, now it doesn't focus. So the idea is the big strip. Well, it focused alright just a minute ago. There we go. The idea is the big strip there, that big blue strip, that's the ground rail. So ideally everything on that rail will be ground. Then we need to join it to the ground on the Arduino. Sorry, not the Arduino, the Raspberry Pi Pico. Wherever that is, let's have a look. There's the Raspberry Pi. So it's it's a third pin along. 1, 2, 3. That's the third pin. So now we've got the ground rail connected. So anything on this rail now will be ground. What else do we need to do? So we need to supply. Right, now we've got the power supplied via this little resistor here. That's going to be supplied by the last pin. So we've got that connected now. We've got a loop there. So now we need to do the button. So we want to connect the. Well, what do we want to do here? Hang on a minute. What do we want to do? We want to connect the button to 5 volts and send that to a pin, and we also need ground. So where's ground on this? Okay. GP14. And we also need a, what do we need? 3.3 volts. So we've got 3.3 volts out there, which is pin 36. I think we'll connect that one first, actually. We need to connect this to the button to power it. So I'll have... Shall we use the... should we use the VCC rail? I think we should. So we skip one and there. So we want that to go to the... it's not really long enough. What was that beeping then? The Raspberry Pi said back end terminated or something. So we want to go from the 3rd pin. I'm trying to get these little jumper wire out. We go from the 3rd pin. Or is it the 3rd pin from it? No, skip one. And go from there to the VCC rail, 5 volt rail, whatever you want to call it. And we want to power the button. Like I said, you might have a different type of one. So everything now on the ground, on that red rail, is going to have 3.3 volts, because on the little diagram here you can see that it says 3.3 volts out on the 5th pin. So that's going there like that. Then we want to come from the pin and we want to go to what do we want to go to? Well, any GPIO pin really. So let's see, where can we go here? What are these pins at the top? These ones? Yeah, let's go to GP16. That will be fine. GP16. I need a suitable one of these. So go from there. Go on. To, or can we go to another one? Now let's keep it easy and just go to 16. GP16. There we go. It's not very nice looking, but it's done. So let's just go over this again. So we've got ground on the Pico to the ground rail. From the ground rail we go to the cathode of the LED. The positive is from here through the resistor through the LED. Remember, we need the resistor to stop that burning out. I'll just show you this again. There we go. And then what else have we done? We've got 3.3 volts to the rail here, to the button. And then from the button, when it's pressed, we go down here to GP16. As far as the putting components in, that's done. Okay, here we are again. Coding. So we are making a what are we making? Quick reaction game. Okay, so we'll start with import. You should probably all know what that does by now. We're going to import machine like we do for every program. And we're going to import utime again. Oh, we've done importy. Import utime, which yeah, you should know what that is now. We're going to import another one. This is urandom. So I don't know if you remember what U meant. It's like micro, like MicroPython. It's basically the random library, but it's minified, if that makes sense, for MicroPython. So random helps us. It's a library that helps us generate random numbers. We want a variable pressed equals false. It's going to take me some time to get used to this syntax. I expect something like this. I expect something like that, but you don't need to do that in MicroPython. Next thing is LED equals machine pin. Right, so we want the LED pin. What was the LED pin? It is that one, which is GP15. Okay, 15. And we want machine pin out. Machine. No semicolon. So again, you should know what that is. It's basically saying, look, we want to use pin 15, and it's an output pin. Then we want button equals machine. In fact, let's go here, copy this. A bit lazy, but people do it. So this is going to be an input pin. So in machine dot pin dot pull down. So I've not shown you pull down before. This is pin down now. What was the pin number for this? The button is pin number, that one, which is 16. Oh, that's easy. Okay, pull down. What's next? Now we need to define a function. Again, I've shown you this. It's fairly straightforward. Global pressed, which basically refers to this one here, up there. Global pressed. And we say, what do we say? So if not, that's new. If not, now in C# you can do that. That means not, but I don't know about this one. So we'll just go with what it says here. So if not pressed, then that means then pressed equals true. Pressed equals true. And presumably there's an else. No, there's no else. Then we want to do print the pin. Print the pin. Right, okay, so what have we done so far? Let me just get out of this. You have to go back down there. Remember that MicroPython indentation is really important in MicroPython, basically. Anyway, what have we done so far? We've got a variable to hold whether the button is pressed. At the moment it's set to false. Then we've got LED. We're setting how we want to use the pin. Button, we're going to set how we want to use that pin. Then define a function. So this doesn't actually get run, it only gets run when we call it. So basically, when this compiles, it creates the function, but it doesn't run it. But it will run the code that's after it. So what we're going to type now, it will run it. So you want to see LED value 1 or true, utime dot sleep, you've seen this one before. What do you want to do? So random, so use the random library. Uniform. I don't actually know what uniform means in this context, but I do know how to use the thing. So 5 to 10. So we get a random number from 5 to 10. At least that's my understanding of it. And we want to say LED. So basically there, utime. Basically what we're doing there is we're telling it to sleep. So we're saying utime sleep. So we're telling the microcontroller to sleep for a random number of seconds between 5 and 10. Then we want to do LED.value 0 or off. So we're turning the LED on, we're sleeping for a random amount of time, and then we're turning it off. Now this is something new, so we want to do button IRQ. IRQ means interrupt request, and it basically means, please can we stop there for a second and do something else. A bit like when you're you know, you've got a phone call or something like that, you're doing something, the phone rings, you interrupt whatever you're doing, or it interrupts whatever you're doing, you answer the phone, possibly, and then you go back to what you're doing after. Or maybe when you're working and somebody calls you with voice or whatever, interrupt. It's interrupting what it's doing to do something else, and then after it's done it, it'll go back to carry on doing what it's doing. Now, the syntax for this is trigger equals machine dot pin dot IRQ rising. So the trigger is a pin rising to high, from low to high. You can do it the other way around as well. Presumably it would be falling. Yeah, it's falling. So if a pin goes from high to low, you can also trigger an interrupt request. And the handler, so it wants to know, okay, what's the trigger and then what's the handler? So the handler is going to be the function that we defined up here, which is button handler. In other words, when a pin starts to rise, call this. Okay? And it knows, it basically returns the pin because it knows it. Okay, what's next? Save it to the Pico. We'll call it reaction 1 dot py. Reaction 1 dot py. Alright, let's carry on. So where are we up to? We need to add a timer start. So where have we got timer start variable here somewhere? No, we want to do that here. Okay, so timer start equals utime dot ticks underscore ms. Okay, so timer start equals the time dot ticks ms. Now I don't actually know what that does. Let me just have a quick read of this here. So it counts the number of milliseconds that have elapsed since the utime library began counting. This provides a reference point. Okay. So it's the same as millis in Arduino. Okay, that makes sense. It's the same as millis in Arduino. So it's basically, a timer from the time the Pico was started, basically. Let's put a space there. Now the next thing we want to do is to print something in the console. So we've got print the pin. We don't really want to print the pin. Reaction. So timer reaction equals utime ticks underscore diff. So this is a function within that library, and we want to say utime dot ticks underscore ms, which is the one that's down there. So what is this saying so far? Utime. So the difference. What was the difference in ticks between the time it started and time of start? There it is, time of start, of course. So we want to get how many ticks have passed since it turned on, and we want to take that away from it, and that would give you the reaction speed. That makes sense, doesn't it? Okay. What do we want to do now? I guess we should run it again. We're going to run. It's when it goes out. Did it print anything? No, it didn't. Oh, of course. So I need to print What do I need to print? I need to print. Let's get rid of that. I don't need to print the pin. I need to print. The reaction speed was str, which makes something into a string, if it's not already. The timer reaction speed, and that is in milliseconds. Alright, saving to starting. Come on, go faster. You gonna work? Doesn't look like it, is it? You're showing a cancel, yes. Okay, let's do that again. Run. Doesn't look like it's running, does it? What's happened there? I'll save it again. Oh, it's not happy. What's happened there? I'll just disconnect it. Connect it back. And then save. What's happened here? Okay, I ended up having to just stop it. Disconnected it, stopped it, and then restarted, and it was fine. Your reaction speed was 333 milliseconds. Okay, so it starts here, it turns the LED on, it sleeps for a random amount of time, then it turns it off. So then we start the timer, and then we get the trigger, and when somebody presses a button, we do this. So it basically gets the time when the LED went off, pretty much, and it gets the time of the handler, subtracts one from the other, and that therefore gives you the amount of time it's taken you to press the button, which actually at the moment feels like it will be a long time because it's very late at night and I'm really tired. Okay, let's restart this thing. Can I do that again? Can I just press stop and start here? Yeah, there we go. $237 milliseconds. I'll try it again. Run script. See if I can do it faster. $233. Yeah, let's try again. I can do better. I can do faster than that. Okay, come on, faster this time. $207. I can do better than that as well. Try one more time. $207 again. I've got to beat that. Hang on. Oh. Okay. Oh, 254. Okay. That's it. That'll do. Right. So I hope you enjoyed the video, and thanks for watching. Bye.